Sorry, also doing that on the screen. So that's fun. And hopefully everyone on the live stream can hear us. Actually, let me go double check that. If you can hear us on the live stream, please put a comment in the YouTube box. Awesome, we have comments. Hopefully everyone can hear us. I'm going to say yes they can, and we're going to carry on chatting. But welcome to the London Java community. So you might realize that I am not Steve Poole. Unfortunately, all our organizers of the LJC are stuck on a train tonight. But okay, I'm an organizer of the virtual Java user group, so you're still got a Java user group. Just a still Java user group. Sam, lovely to meet all of you. Everyone on the live stream that's watching, hello. Please put in the comments where you're watching from. But tonight we're going to have an amazing session by Rod. But before we get started with that, I just wanted to tell you a little bit about who we are here at Tessl. So I also work for Tessl, the space room. I love community. I don't know if you noticed. And I run another community called the AI Native Developer. And that is all about AI content for software engineers. So I know information out there, use parts, just find stuff on Java or Python or JavaScript. Now you type in Google AI and it's everything from what's useful for your grandmother to what's actually useful for engineers. So that's why we launched the AI Native Dev. And we also do articles, podcasts. We've actually just recorded a session with Rod today on the podcast. So if you enjoy his talk today, when that goes live, please listen to the episode as well as host a number of different events. So I run a monthly meetup in this space, but when I'm not doing that, I then host a bunch of events. So last night we had Sneak and Kodo, the night before that we had LLM London, next week London JS and the CTO craft community. So if you're looking for cool developer content in London, just check out the list on the site, and you can just hang out with me. Manny hangs out with me all the time. We run lots of events. And we also run a conference. So for anyone watching online, we do have a free virtual ticket if you want to watch the live stream. But for anyone in person, we just ran this in New York in November. We're now in London in June. It's a 2-day, 3-track conference, plus workshops, plus conference, plus party, and that discount currently makes the ticket £90. That's your food, that's your drink, that's everything. We want to make sure the content is super accessible, rather than begging and pleading for an unbeliever. So please join us for that. Just a little bit of housekeeping for anyone in the room. The Wi-Fi are on the QR codes, wherever you can find them. The bathrooms or the restrooms are back where you came up in the lift. The restrooms there, we're looking for them, and there are no planned fire alarms. So if it goes off, there's an emergency exit that way, an emergency exit that way. If you do want to join us on Friends, the slide is going to disappear very soon, but the QR code is on the screens in the kitchen. You can come with me because that's the event running. And we're almost finalized on agenda. The CFP closed earlier this week, so we're slowly updating it. But hopefully you'll see some familiar Java faces. I think we've got Oleg here, we've got Simon, we've got Chris. So yeah, assistant Java humans. But that's enough from me. Tessl itself, anyone here use Skills? Awesome, so Tessl is a package manager for Skills. You can version them, eval, maintain, check it out. I'm not going to tell you anything more about it. But please check it out, it's lots of fun. Manny's also used it, so he can tell you all about it. But that's enough from me. I'm going to hand over to Rod, and he's going to get started. So over to you, Rod.
Thank you, Sam. It's good to be back in London. Actually, my career in Spring, early years in London, and most of the experience that went into Spring, actually I acquired while working on JVM applications. Okay, so before I get into any details of code, let's talk about why I created Embabel. Why do we need another framework? Specifically, why do we need a Gen AI framework on the JVM? The reason for that, I think, is what we need to do in Gen AI. So broadly speaking, there are two categories of AI, Gen AI use cases. One work amazingly well, the other doesn't really work very well. The one that works amazingly well is consumer-facing things, personal assistance things. Think about ChatGPT, which was the first breakthrough product, Claude Desktop, Claude Code, any coding agent. All of these are in personal assistance category. In the other bucket, I would place things that automate business process and are the kind of things that bring additional value, AI-enabled value to the enterprise apps that we all work on. It's very important, I think, to understand that distinction because I think not sufficiently it causes lots of problems. Clearly, in the case of Gen AI for personal assistance, it is absolutely game-changing, right? I mean, it literally changes everything. How many people are using coding agents daily? Excellent, really good. Yeah, I mean, the reality is I know there are some constraints in organizations where it may not be possible because of policy, but fundamentally, once these tools become available to every developer, they are amazing productivity enhancers. There's no question about this. They can make us all better, faster, the best, most productive version of us we can be as developers. Similarly, I use extensively AI to do things like research topics, draw up competitive analyses. All these kind of things are a very big part of my workflow, and I'm generally very happy with the result. So that bucket, the personal assistance bucket, is the thing that works. The things that don't work tend to be in the other bucket. The how do we bring AI to improve business processes. So why is this so? The answer for why personal assistance works so well is that we are in the loop. We're part of the system. It's not fully autonomous. We get to say no. This is why the runaway winner in terms of paid AI solutions for professionals is coding agents. That is because the coder is in the loop. This is massively enhancing personal productivity, but we have a few unusual qualities around coding that don't apply to business processes. Firstly, we have the fitness functions like compilers, unit tests, other tests, right? There are automated ways of knowing whether something is true or not. And that's great because if you've got an automated check for something, you can do autonomous round tripping. Secondly, we have the developer in the loop. And the developer is armed with this wonderful tool that we all know, but the rest of the world doesn't necessarily benefit from: version control. Version control is miraculous. It means that if something really bad happened, it's quite possible to make it go away. So there's no record of bad things. Not the case when you're trying to automate business processes. So, coding agent most of the time will come up with pretty good suggestions, and you might accept them, review them, accept them. Sometimes it will come up with really terrible suggestions. They're gone forever. Magic, go away button, git revert, gone. This doesn't work with business processes. Air Canada tried a couple of years ago. Their chatbot gave someone an unbelievably good fare. The person accepted it, and Air Canada decided to try to git revert this. Didn't quite work because the person took them to court and quite rightly won, because you can't put something in front of a customer and pretend that didn't occur. So hopefully I've laid out some of the reasons that there is a very clear distinction between what works amazingly and what doesn't work very well, which is AI in enterprise. The reason this distinction is important is because people naively think that a lot of the things that work really well for consumer-grade AI will work really well for business process AI. And they don't. So one of the things that you can tolerate and indeed celebrate and benefit from in personal assistance is giving models a lot of autonomy, right? You can give a smart model a whole bunch of tools. The model chooses which tools to call, what order to call them in. Most of the time, the results are really good.
sometimes they're surprisingly good, occasionally they're bad, and it doesn't actually mean anything terrible happens. Can't do that with business processes. You've got to be able to explain what you did. You have a whole range of concerns that are rather different. So this is why Embabel exists. So when we had that amazing moment when suddenly, you know, ChatGPT 3 became really good. I was thinking, okay, how do you apply this in enterprise, which is a very different and tricky problem. And it seemed clear to me that firstly, you needed to bring much more structure to, rather than purely rely on model autonomy and, well, honestly, when Embabel first started, tool calling was fairly new. But in terms of the present world of where we are, rather than giving models too much autonomy, we needed to impose our own structure and manage that structure without leaving everything to models. Secondly, there was the question of language. What language is the appropriate way in which to Gen AI enable your business applications? And I think the answer is actually pretty clear. The answer is the language those applications are written in. So this is a very important point. A lot of people make the mistake of equating Gen AI with Python. This, in my view, is completely wrong. Because when you think about what you want to do with Gen AI for any particular task, you've got to look at the adjacencies that go with that task. So what are you talking to? You're talking to existing business logics, existing enterprise systems, you know, backends, databases, SaaS services, whatever, and you're talking to an LLM. Which of those adjacencies is most important? How many people are familiar with what calling an LLM looks like at HTTP level? It is ridiculously simple. You can do it with curl. Like when you get into the tool calling dance, it's a little more complex, but fundamentally, this is something that even without a coding agent, any good developer could write the most basic part of an agent framework in any language in an hour or two. It's really that simple. So this idea that any language has an inherent advantage in working with LLMs is kind of ludicrous. And I mean, as an additional proof of that, if you look at, say, OpenClaw, which is obviously not very relevant to enterprise, but having a big impact, it's not written in Python, it's written in TypeScript. Guess what? Peter Steinberger wrote it in the language that he felt most comfortable with, which was clearly the right choice to build the product he wanted to build. So this brings us to the point that if our enterprise applications are in Java, which most often they are, we want to Gen AI enable them in Java. That will give us access to our business logic. It'll give us access to our domain models. It'll give us access to the way that we test things. There's a whole bunch of things that will be beneficial in that case. So let's get a little more specific. And let's talk about the approach that Embabel takes, which I believe is novel, which is why it needs to exist. So we're going to be talking about the Embabel agent. So if you Embabel organization on GitHub, Embabel agent is the core project. But we're going to be starting with the Java agent template. So this is a GitHub template repository. So you can use this. If you click on use this template, you can create a new repository very, very quickly and get up and running in, you know, a matter of very few minutes, well under 5 minutes. All you're going to really need to set up is an API key for most likely OpenAI or Anthropic, or you can also connect to other local LLMs, for example, using Llama. But typically, you'll create a repository, use your OpenAI API key, and you'll be up and running very quickly. Okay, let's have a look at what the most basic use of Embabel is to introduce our API, and then I'll talk through what I think makes it different and very interesting. So this particular template is a Maven project. Obviously, if you prefer Gradle, it is also very easy in Gradle. It takes the Spring Boot parent. So there's nothing in the POM setup. There's nothing magically Embabel-y about this. This is a Spring Boot project to which we've added Embabel via starters. So if you're familiar with Spring and Spring Boot, getting started with Embabel is really, really easy. So now we just bring in a few starters. So for example, we have the Embabel agent starter here, where we've got the current version, which is 0.3.5. We are working towards 1.0. It will, I would say, be 4 to 6 weeks away. The API is pretty stable at this point, so it's possible to build without too much concern that your code's getting broken. So you've added the starter. The other thing that you need to do is you need to add at least one model provider. So models typically have their own like little bit of code to smooth over them. So for example, Anthropic, Olama, LM Studio, Bedrock, all of these things also use the fewest that you need. Okay, when we do that, we can start it up. And like many of our examples, this starts off with Spring Shell. Spring Shell is kind of pretty cool way of making interactive applications. So Spring Shell enables you to define components that essentially map to shell commands. Obviously, this is not something that you do in production. Like in production, you kick agentic workflows off through, just normal calling them from a controller or a service or something. But it's very easy to get started. Okay, let's have a look at some of the log output here. So it came up, it detected a bunch of models. In this case, I have OpenAI and keys, so it's detected that I've got those API keys and made those well-known models available. It's now compiled a list of the LLMs it can use, and it's also printed out Yoda and Feel the Force, and we'll get a kind of Star Wars feel to the log messages. This, a bit more than a mere novelty, this actually reflects something important in the design, which is that all info level logging is driven by events. So there's debug level logging in the classes that are being executed, but the info level logging comes from events emitted by the framework. I think this is a really good discipline because every one of those events you can pass over the wire, say with SSE to a client, you can write your own code to react to them. So it's actually not only kind of fun in that we've got various logging personalities, but it actually has a serious point in that it ensures that we expose, all these things you can add listeners to. If you don't like Star Wars, you can try some of our other logging personalities, or alternatively, you can get rid of this property altogether, and then you'll get boring normal logging. Okay, so now let's ask it. Now it's up. Let's ask it what models it knows about it, and it'll show us the models that it has, and it also has a default LLM. So one interesting thing about this, unlike say something like Spring AI where you purely call it to do a certain thing, Embabel has this notion of a context that it understands, what we call an agent platform. And there are various ways in which that becomes really quite important in more advanced applications. So it knows about a set of models. It also knows about a universe of tools that will be available to call, and it knows about its own agentic workflows. And this is quite important for extensibility. But before we get too carried away with fancy workflows, let's look at the simplest thing you can possibly do with Embabel, which is just make a single LLM call. So, if a lot of people think, well, AI is really easy with Python, must be really complicated with Java. Well, make up your own mind just how complicated this is with Java. So here we have a record called injected demo. It is actually a Spring at component, which means that Spring will inject it because we have the Embabel starter, you can inject the Embabel AI interface. The AI interface is stateless, thread safe. You can use it to get what you want. You can use it the same instance multiple times. So we've got this at the class level, and now we can call it using our Fluent API. We've put quite a lot of effort into making the API really nice, and I honestly think it's significantly better than any API for other AI frameworks on any platform, and it's strongly typed. This is a core value of Embabel, that we try to make things strongly typed as far as possible. Okay, what are we saying here? Well, the key thing here is the prompt. You just woke up in a magical forest, invent a fictional animal, and note that we're going to return a type. We've got a generate text method as well, but one of the key things in building robust and predictable applications is that you really should use as much structure as possible. Just because LLMs are amazingly good at generating text doesn't mean that is what you should always use them for. They're also really good at generating structure. And guess what? If you do everything in text, it's very hard to reason about it, right? The ways in which you can work with text are either pretty clumsy, like say pattern matching, regular expressions or whatever, and quite error prone, or they're non-deterministic and ridiculously expensive, like embeddings for similarity search, or using an LLM, which is unpredictable and super expensive. So the more structure you can bring, the better. And in this case, animal is a very simple record, which only has 2 fields and they're both strings. But imagine if animal had, for example, fields of enum types, ints, doubles, right? You can also ensure that you coerce things into types that you can reason about. And then, you know, for example, guardrails around certain values being illegal. So coming back to the actual code, the first thing that we do if we want to invoke an LLM using the AI interface is we choose the LLM. So in this case, we've said with default LLM. Something else that we could do is choose an LLM by role, and we can configure the role in our application.properties or application.yaml. You could choose an LLM by name, like you could say model GPT 4.1 available at Woolworth. And you can also specify hyperparameters, things like temperature, max tokens, and that, as you would expect, will work portably across different LLM providers. So in this case, we've chosen our LLM. Now we actually no longer have an instance of the AI interface. This is a Fluent model. We have an instance of Prompt Runner. So Prompt Runner enables us to do things like specify the type that we're. Why would we have this here? Remember what I said about strong typing. So after we choose what we're going to create here, we choose to put in a couple of examples. This is what called few shot prompting. So LLMs are really, really good at learning from examples, and very often we want to do this. So we, you know, the good examples, these are bad examples, and it will really help the LLM a lot. But because we have a strongly typed API, our examples are not just putting JSON in the prompt. The examples are actually creating types of our desired class, and it's type checked and auto corrected in our IDE. So the under the covers, the framework does the work of generating the prompt elements that will serialize this to JSON so the LLM will understand. The framework also does the work of taking the response from the LLM and marshalling it back to the type we want, and also giving the LLM a JSON schema so that it can see what's expected of it. So let's run this. We can do it by typing animal, and We got an animal, name is glintwing and species is luminox. So let's have a look at animal. If we look at the animal class, we can see that the record has on one of its fields, on the species field, it has a Java Beans validation pattern annotation. So what Embabel will do with that, if a type is so annotated, is it will put it in the prompt and tell the LLM what the rules are. And if the LLM gets it wrong, it will actually turn it around and go back and say, hey, this field is wrong because of whatever. In this case, it's probably, actually, to be honest, overkill. We could probably get away with taking those examples out because the pattern annotation will be highly effective. But, we put a lot of effort into trying to make things as predictable and as validatable as they can be. Okay, so that's the simplest thing you can do with Embabel. And it is actually quite important because even though we're not talking about fancy multiple step workflows here, we are able to use this approach to just put a little bit of Gen AI into our applications. So, and there's an important category of problems where, for example, integration between systems, where it's relatively simple, but it's just a little bit too complicated to completely automate. And the code to do it would either be impossible or messy, yet an LLM can do a great job of, say, relating values from two different systems. So there's a whole bunch of useful things we can do with that. However, what is more exciting is when we use workflows. So multiple step agentic workflows. This is where with Embabel, we introduce an original idea. So firstly, if you're trying to build enterprise applications using Gen AI, as I said, you can't let the models be super autonomous, right? You've got to control through your code and what you did, you've got to control the steps that are executed. That way you can audit it, you can check it, you can put more guardrails, all of these kind of things that are really important to mission critical applications. So that brings us the question of how do we handle the control flow? You could just do it in code. The problem with that is things can get fairly complicated. And also LLM calls often need to be retried, right? There's a considerable value in having this broken out so it can be managed by some kind of runtime. So we could orchestrate by using something like a state machine. This is what in Python LangGraph uses. So it breaks things, encourages you to break things down into steps, which is great because the steps will make things more predictable, smaller steps, but it forces you upfront to determine how things are linked together through states and transitions. I mean, this is certainly a lot better than giving your model total autonomy, but it does have some problems. One problem that it has is state machines tend to be fairly painful to rewire. If you want to add another state, you've got to mess with your transitions. So it's somewhat hard to extend. And also you've got to decide all the potential transitions up front. Crew AI in Python does something somewhat similar, where you basically specify a sequence and the sequences can kind of nest. But you're deciding upfront what order things will occur in. Embabel takes a different approach. Embabel takes the approach of introducing a planning step that is smart, but is not using an LLM. So we use an algorithm by default that came out of the gaming community called GOAP, Goal-Oriented Action Planning. So what this is a path-finding algorithm that looks at world state and tries to pick a path through a number of actions to a goal that will satisfy a desired world state. This algorithm, under the name GOAP, appeared in the mid-2000s and has been very, very popular in gaming. It actually is very similar to really old AI algorithms that came out in the late 50s, like general problem solver, which I remember like in computer science at university. I mean, that algorithm was like over 30 years old when I was a student. It is interesting how things keep coming back. It's been actually, with when I was at university, it's what we now call the AI winter, where our head of the computer science department at Sydney University was one of the few people who still really believed in AI. And he used to say bitterly that AI is the set of things that don't work. And whenever you make something work, people say, yeah, but that's not real. How time algorithms like neural networks were like old. They were real algorithms in the late 80s. And turns out that if you have an unbelievable amount of memory and an unbelievable amount of data and really good GPUs, you can do pretty algorithms. Okay, coming back to why we chose Go. We wanted a way of orchestrating steps that would be deterministic, because we think that's very important, that would be explainable. So you can not only get the same result every time, but you can explain why the path chosen was the same every time, but also has some advantages that you do not get with, say, a state machine. It has the that it's computed at runtime. So it's possible that in different states of the system, it might choose a different path, because a different path would be optimal. It is aware of cost. So you can assign costs, even dynamic runtime calculated costs, to different steps. So it can make different decisions in changing scenarios. And also, if something fails, it might be able to find another path. So it can actually replan. So how this works is we have a world state. The world state is basically a set of string keys that map to true, false, or unknown. And a goal has preconditions, which are the conditions that must be true for that goal to be achieved. Actions have preconditions, but they also have expected postconditions. So this means that if you know your world state at any point, you can actually work out a particular goal. Or alternatively, you can see that there's no path to a particular goal, which is actually a pretty useful thing as well in terms of explainability, to be able to say, well, I didn't do anything because I can't see any legal way of progressing from here to where you told me you want to go. Preconditions are absolute. You can't invoke an action, you can't achieve a goal unless its preconditions are satisfied. The postconditions are kind of facts. So, you call a particular action, you cannot call the action. The framework will not call the action unless its preconditions are satisfied. But its postconditions are kind of a promise. It says, I'll do these things. And the planner runs after every action invocation. So the plan start, look at the present world state, look preconditions of the goal that you with a path, it will execute the first action, then it will replan. So for example, if that action didn't make the expected changes in the world state, either there might be no plan now that works, or alternatively, it might find an alternative path. So I think considerable advantages in this. You might think, wow, this all sounds pretty complicated. Do I need to think about this stuff all the time? And the answer is no, you don't, because we, again, leverage the Java type system. So actions are typically Java methods. Java methods have arguments and return types, and it figures out the preconditions from the parameters to method, and it figures out the expected postcondition from the return type of the method. So, 95% of the time, you don't have to explicitly write any conditions yourself, because they're inferred using reflection by Embabel looking at your action methods. I know that sounds very theoretical. Let's look at some code. So now we're going to look at a really simple multi-step agent that writes a story using one LLM and one prompt and reviews it using a different LLM and a different prompt. So one of the major benefits with any agent framework, not only can you break things up into smaller chunks, but you can use the appropriate LLM for each operation. This is really quite important because it turns out break things up, you no longer need to use a God model, right? If you rely on a really big prompt with loads of tools, you better be using Sonnet 4.6 or GPT 5.4 or the biggest model you can get your hands on, and you will get better results. Whereas if you break things up into smaller chunks with focused prompts, fewer tools, you can very often use much smaller models. This is, a good thing in general, but it also can be particularly important in enterprise scenarios because you may not need to use a model in the cloud. You might be able to run a model on hardware behind your firewall or in your colo or somewhere where you're comfortable that you're not, for example, giving the data to a model provider you might not trust, or alternatively that your customer data really never went outside of your control. So that's a very important benefit. Okay, let's look at our action methods. So here we have the write and review agent. So this is a class that's annotated with @agent. So @agent in Embabel means this thing will contain steps that and goals that will be useful. So it is a Spring @component annotation. So if you're familiar with how Spring works, if you have, for example, @controller, that both says that it is a Spring MVC controller, but also that Spring should inject and manage that object instance. So @agent is the same thing. So we're going to get all the things that Spring does for us if we annotate something with @agent, but we're also going to get extra Embabel stuff. So the most important extra stuff that we'll get is we will get it to understand @action annotations. So here we have a simple action that crafts a story. So notice the output of it is the story type. The input is user input, which is a type that ships with Embabel, but it's actually not otherwise special. It's just a precondition. It's just the domain object. We've met the AI interface before, and you can inject that into any of your methods if you want to use that, which you most often do. So this action can be read as an action that has a post condition of story and a precondition of user input. So no user input, you can't execute this at all. So that doesn't have a goal, however. So this has a goal. So this has both @action and also @achieves goal. @achieves goal is a convenience annotation that also creates a goal. So what that says is if you've successfully executed this action, that satisfies the goal of the story having been crafted and reviewed. So it's really, so here we've got two actions. There's a goal that will be satisfied by the second action being executed. So here you can see that it emits a reviewed story and it takes user input and story. So it can't run before the action has run. So as you can imagine, in order to make this work, as with any agent framework, you need to have a blackboard or some way of like persisting what's happening in the current, as we call it, agent process. So if we run this, what it's going to do is firstly write the story, and then it is going to review it. If you look at the prompts, you will see that the prompts are built in strings inside Java methods. There are two ways of building prompts in Embabel, you can either do it like this inside your code, or you can externalize it to templates. So by default, we use Ginger, Jinja, templates, which are the de facto standard in the Python world, where there's obviously lots of prompts waiting for us to be able to benefit from them. I would say, in general, put your prompts in Java code or Kotlin, if you prefer Kotlin. The main reason to externalize prompts, in my experience, is chatbots. Chatbots with the best will in the world have really, really big prompts. Because a chatbot's pretty open-ended, you've got to give it lots of instructions, and you don't really know what is going to do. It's much harder to skinny down your prompts. But if you're breaking up a lot of business processes into multiple steps, can and should skinny down your prompts. And then we've got multi-line strings in Java now. It's not actually that bad to have it in your code. What's more is you typically, if you have these pretty small prompts, you don't spend a great deal of time prompt engineering because they're not that fragile. And we can, because method, you can use anything that's in scope. It is type safe, right? You can compute things from functions. You can do anything you can do in perfectly normal code. So here it says create a short story in a certain number of words. And this is actually using a mixture of things that were injected by Spring and things that came from the user input. So let's just run that and see what it does. So what do we want a story about? Suggestions, come on. Let's think of a story.
Spring's Day.
Spring?
Spring's Day Out.
About a spring day out. That sounds nice. Well, we actually felt like we had some real spring weather. Okay, so it is going to give us quite a lot of logging. This is set out to do verbose logging, which basically is telling us all the conditions, all the world states we've seen. And this is what it output at the end. Story on a vibrant spring day, the air hummed with promise. Lila wandered through a meadow where flowers whispered secrets to the breeze. Suddenly a curious fox, its fur shimmering like copper, etc. Yeah, I hate LLM writing, but don't blame me. And then the review has a little bit of criticism. It says the narrative feels slightly thin, but this was the second action that had a different prompt and a different model. So here you can see that at the end it tells us some interesting information. It tells us which LLMs we use, and I configured those two calls in the prompt runner to use different LLMs. And it counted the tokens and it calculated the cost. So for well-known models, Embabel actually also will know the cost for input and output tokens and the knowledge cutoff. This is quite important because particularly when you get into tool use for things like searching the web or many other kind of tools, the model doesn't know what the data. And its knowledge cutoff is very often between 3 to 9 months ago because there's a bunch of stuff that they do when they've trained a model for like safety checks, etc. They don't release them immediately. And there are a whole class of things where if the model doesn't know the current date and know the knowledge cutoff, it will not behave optimally. Embabel puts those things in automatically, so you don't have to worry about it. It will always put them in. And as I said, if it knows the model, it will be able to calculate how much it cost from the input and output tokens. If you're working with a model that Embabel doesn't know, you can also provide that additional information yourself. If you're dealing with a fancy, longer running workflow, you can also provide a tool that will enable an agentic loop, enable the model to see how much it's costing and whether it's over budget. So you can actually expose that to get behaviors that might differ when it realizes that it's either under or over the token budget. So for example, you might want it to search for something really, really exhaustively, and you could tell it that you really, this is super important. You want it to spend $1 doing this rather than just give up quickly. So that's an interesting way that you can provide some further control. Let's go back now and just try a few little changes just to see how the API, how easy it is to use the API. So you Auto LLM, which in this case I think is GPT 4.1, with temperature 0.7. This is relatively neutral with ChatGPT. Everyone know what temperature is? Temperature is basically, how high or drunk your LLM is. So, 0.7, I don't know, your LLMs have a really small beer. But now we're going to get this LLM really wasted. So we're going to take the LLM to 1.2. Generally with the OpenAI models, when you get to about 1, the range is notionally 0 to 2. When you get to about 1.4, it actually typically spins off into some bizarre mix of Python, C, and English. At some point, 1.2, it'll just probably be a bit wacky. Actually, we'll go 1.29. Most likely it'll stay in English at that point. And we're also going to be really mean to this wasted LLM, and we're going to make the reviewer mean. Like if this produces something pretty strange, which it probably will, the reviewer who's got default temperature, which will be 0, so it's not going to cut it any slack, we're going to change the persona of the reviewer. So this is using the persona model, which is a kind of prompt contributor we have. It's probably not that important to explain that right now, but let's say you are renowned for your direct, critical voice. You can be trusted to warn the reader about anything that is trite or derivative. You pull no punches. So now we are probably setting a trap for this poor LLM, and let's see what comes out of it. And we'll get it to do the same story. Okay, on a bright spring morning, Lila stepped into the whispered symphony of blooming cherry trees. Yeah, definitely a bit high. Birds chirped secrets, crafting melodies for an old saxophone. Okay, yeah, okay, that worked. Review. This reads like a greeting card that wandered into literary fiction. The prose is aggressively sentimental, whispered symphony, worries melting, glow warmer, hitting every cliche in the emotional manipulation playbook. The story confuses aesthetic imagery with substance, a competent effort, but derivative and hollow, 2 out of 5. So it is very easy across different models to consistently work with everything you want to do with LLM invocation. Okay, what we haven't discussed so far is a critical part of making LLMs useful, and that is tool calling. So remember that one of the fundamental challenges with LLMs has always been hallucination. So hallucination can refer to the fact that LLMs can just make stuff up. But on the other hand, if we don't build systems appropriately, we can force them to make something up, right? Like if you don't give them relevant context and something isn't in their general knowledge, there's a high chance they'll start to make. So there are essentially 2 ways that we address this. One is RAG, retrieval generation, which is we dynamically build a prompt that has information that we think is relevant to this particular request. And the second one is tool calling. Tool calling is actually probably now the more important of those two. So for those of you familiar with traditional pipeline RAG, I would argue it's not really best practice anymore, and it has severe limitations. Tool calling is really the modern way to get real-time information to your LLM. So tool calling actually involves a somewhat complicated dance. LLMs are completely stateless. When you have a conversation with ChatGPT or when you see tool calling handled by a framework like Embabel, there are actually multiple invocations of the model that are all stateless. And the infrastructure, the framework is handling that state. So the way tool calling works is, let's suppose we ask one of these models what the weather is in London. Even though we've helpfully told them the date in London, we're obviously not going to put the weather in as well. Like, where would we stop? Are we going to give them how much diesel is per litre, right? I mean, you want, at some point, you have to draw a line, say, this is what I'm going to provide. And if you, the LLM, need to know more, I'm going to give you a way to find out more. So the way in which tool calling works is you pass to the LLM a set of tools. And you say, for example, here's a weather tool. If the user asks about the weather, you can invoke this. And by the way, when you do that, you need to pass whatever it is, the name of the city and country, or maybe it's the latitude and longitude, right? To tell you what you need to pass to this tool to make it work. So that under the covers will cause an extra hop. Okay, let's have a look at how tool calling works. So we've been looking at Java Agent Template. Now we're going to go to another of our projects, Embabel Agent Examples, for a more complex example that does a more complex multi-step flow. What this does is, from user input, extracts the name and star sign of a person, or attempts to extract the name and star sign of the person. Then it calls a horoscope service to find their current horoscope. Then it uses web search to find news items that are relevant to that horoscope. And then it uses another LLM call to actually make a write-up that references everything it found. So there's multiple steps. There's also, although I don't have time to go through it, there's an additional path where if it doesn't get the full information, it can ask the user for more information. So it illustrates that ability of GOAP to go through a different path. So let's start this up. And we will, so this one is a bit slower because it's got a number of tools. So if we ask it what tools we've got, we'll see that it's got a number of tool groups, which include things like it's got Google Maps that are used in another example in this. It's got math tools, and it's got web search tools. So let's see how we add tools. So as I said, the first thing it does is extract from user input a star person. So star person just has name and star sign. Notice also you can use JSON property descriptions from Jackson if you want to provide further information to your LLM in addition to the validation things. I honestly find that I don't tend to do that much, because if you've done a decent job, the LLM will be able to understand your naming, right? Again, this is the kind of thing where if you're wasting context on description, you probably need to ask, why is this confusing? Because an LLM will probably get it right otherwise. So we're creating the star person, and here we're using the create object if possible method. So what this does is says to the LLM, try to create this structure. If you can't create this structure, return, well, say you can't, and tell me when you create it. So that means in Java, this would be annotated as, it should really be annotated as nullable. If you were writing this in Kotlin, it would be, indicated as nullable with the question mark. So when we've done that, we now have this action that could fire, which is retrieve horoscope. This action doesn't use an LLM. This uses a Spring service that was injected. Horoscope service was injected. Very important. By breaking things down into steps, you can do things that don't require an LLM in code. What percentage of the time should you do something in code if you can do it in code with an LLM? In round figures? 100. Yes. So, and once you're breaking things down, you get the ability to do that. It's going to be faster, cheaper, easier to reason about, easier to debug. So in this, now we get our horoscope. Now we could potentially invoke this action, which is find news stories. So we've got our star person and we've got a horoscope, and we're just using the AI, which is not a precondition. That's just what we call to do prompts. And we have also specified here with tool group, core tool groups web. You can either add tool groups that are configured at server level, or you can actually add an individual tool instance, which is very easy to do. Like you could say with tool object, new foobar. And let's create a foobar and see what a foobar tool object could look like. So this is the possible LLM tool. It uses our @LLM tool annotation. And in this case, it has no parameters. But if we had parameters, they will be exposed to the model. And like other frameworks, will do the work of explaining to the LLM how you map this thing onto Java. People have heard of MCP. MCP has kind of taken the world by storm as a de facto standard for tools. And MCP is quite important. And the example that I'm going to show here is MCP. Embabel is great for both consuming and exporting MCP. But nevertheless, in enterprise, these kind of tools are more important, because imagine this wasn't just a foobar. Imagine this, for example, as a Spring service. Imagine it was injected with stuff that gets it, important from your system. And now you are able to expose to the LLM safe operations that it call. You don't have to go through the hoops of MCP. This is part of the reason that it makes a lot of sense to do your Gen AI in Java, if your applications are in Java. So let's go back to where we were, and I will actually comment out the foobar tool object because we don't want it calling it. And let's actually run this and see if it works. So we will say, Linda is a Scorpio, find news for her. And it should start to create a plan. You can see the world state here is a little bit more involved because there's more moving parts. And at the end of the day, it's going to start extracting a star person. It's got a star person. Now it's replanning. Now it's retrieved the horoscope. The horoscope came back almost instantly because that was just a REST call. And now it's using the web search tools. So you can see here, it called tool Brave News Search and received whatever this was. And at the end, it's going to write it up. Today, the stars are doing a cosmic vanishing act with your horoscope. No predictions for you, but fear not your secret Scorpio powers, etc. And I think that REST service might have failed. This is what happens, unfortunately, when your examples rely on somebody's like horoscope service sitting on Vercel or something. That's probably something that isn't enterprise grade. It actually worked an hour ago when I tested it. But guess what? That failure was in good old-fashioned code. It was invoked from a REST service, not from AI. So Tools are the true superpower that makes your AI agents connect to your business. They're generally more useful than relying on, retrieving context up front. Some examples of tools include tools for agentic RAG. So traditional RAG pipelines work by, you look at what the user asked, do a vector search for things from your vector database, and then you shove that in the prompt. This might help you answer this question and hope that you've got the answer. There are some fundamental problems with this. Firstly, vector search is not the right search for all cases. Secondly, we have to chunk documents to get them to be searchable, right? There's doing a vector search for a massive document. We can't put a massive document in the prompt. It will cost a fortune. It will overwhelm the prompt. So basically what we need to do is find relevant content. So the first step in pretty much any RAG system for document retrieval is you chunk your documents into much, much smaller chunks. Then you try to retrieve the chunks that are relevant. With traditional pipeline RAG, you do that up front. You do vector search, possibly hybrid search involving string matching, but it's all done up front, and you just hope that you got the right things because they're in your prompt. With Agentic RAG, it instead is tool-based. So with Agentic RAG, we don't do the search up front, give the LLM tools to do the search. So the way we handle that out of the box in Embabel is we give you any of the stores that we support or your own store supports. So for example, the vector search, it could be BMI 25, text search. It could even be regular expression search if something supports that. And it can also be structural things. So with chunking, there is no perfect strategy, right? You take a bunch of big documents and you chunk them up. Well, inevitably, whichever strategy you do, some of the chunk boundaries are going to mess things up, right? You're going to look at a chunk in isolation. It's like, it doesn't make a lot of sense. And you're very often going to get misses because your retrieved content doesn't make sense on its own. And there was no way to put it together to make sense. With Agentic RAG, you can solve that. So with our Agentic RAG, the LLM, if it sees a result for the chunk, it can ask for the next chunk or the previous chunk. So, and LLMs are smart enough to do this. So, and this is definitely an area where it actually does make sense to give your LLM autonomy. So if it sees that there seems something really promising here, but I need to see the next paragraph, it can go ask and get it back. So this is our Agentic RAG, which you will find an example of in the Urbot project. And I'll just show you how you set it up. So this is for the user documents here. So we use the toolish RAG class for this. You give it a name, a description, and you give it a search operations interface. Search operations, we support out of the box for Neo4j, Lucene, and PG Vector and the file system. It's quite easy to write it for anything else you want. So, you could write it for some of your own services, perhaps, and you just implement as many of the methods as make sense for your scenario. So, for example, with Neo, you can do some graph traversal that you can't do with other things. But say with both PG Vector and Neo, you can retrieve the next and previous chunk to get that structure to work. So very easy to do. We also support metadata filtering. So in this case, we have a context property on documents and hence on chunks. So we can narrow it to the things this person is allowed to see. What's more, we use multiple instances of the toolish RAG type in the same prompt. So for example, we could have We could have documents for the user. We could have documents for all users. We could have documents relating to some topic that they're talking about in the conversation. And this brings us to tool calling and some of the fancier stuff that we do with that, which I think is quite important and innovative. So hopefully you're getting the impression that, we didn't start by trying to imitate a Python framework. We are genuinely trying to do things that we think are novel and valuable, particularly in the enterprise case. One of those is the stuff that we do around tools. Tools, as I've said, are critically important, but they also have challenges. One of the fundamental challenges is getting LLMs to call the right tool. The most critical workaround for that is break your flow up into steps so you're not purely reliant on that. But nevertheless, there are going to be scenarios, particularly in chatbots, where unfortunately you are going to have to work with quite a few tools. What we give you is the ability to organize your tools in a way that reduces the top level number of tools. Virtually any LLM, even the really good ones, will begin to degrade in the predictability of their performance when you have more than a certain number of tools. Really good model will probably cope with about 40 tools. There is no model. If you go over 100 tools, the performance will really degrade. It's also going to cost you a fortune because, when you add with tool, you're actually getting a lot put in the prompt that goes to the LLM. So, it really does cost tokens, and tokens cost money, time, and predictability. So we have several pretty fancy tools, one of which is what we call the unfolding tool. So this is a top-level tool where we say, call me to do X. If the LLM calls X, it rewrites the history so that it now shows the child tools of X. So the LLM will then be able to invoke one of those. Toolish RAG is a good example of that. There could be anywhere, depending on the underlying search operations, there could be anywhere between 5 and 10 tools underneath a toolish RAG instance. So imagine we wanted to have 5 different document stores that a user could access. Not unreasonable, like the user's own documents, some groups they're in or whatever. We have 2 problems. Suppose we had 10 tools. Well, now we've got 50 tools, and that is really going to degrade performance. Secondly, what do we call those tools? We'd have to find some way of disambiguating the naming, right? So that's going to consume even more tokens. Instead, what we can do with the unfolding tool is have 5 tools, top-level tools, and one of them say, call to access the user's own documents. Another one will say, call to access our policy documents around cancellation. And if the LLM calls one of them, it rewrites the tool calling history for the next invocation to expose the child tools of that. So this enables you to work with a far, far greater number of tools. We also have what we call an agentic tool. The agentic tool is like the supervisor pattern that you see in frameworks like Google ADK or LangGraph also offers it, where basically you're using an LLM to do a form of planning. We don't encourage that as the default choice, obviously, but we do offer it, and there are some cases where it's useful. And so this basically means we've got a top-level tool that has other tools that it can choose from. So it's a different way of decomposing. We also have a version of that, which I believe is unique, that we call the playbook tool, where it can unlock some of the tools based on the state of what it's already done. So, which means that you can kind of enforce a workflow. So you've got for example, there's one repository tool we have in one of our internal apps, which has create, delete, find, etc. To create, you need to know what the schema for the particular entity is. So we don't let create get called until the LLM's called the describe for that entity. Whereas you could, at least in theory, delete something without knowing what its full structure was. So I think I'll stop here and take questions. But hopefully, I've encouraged you to think a few things. Firstly, Java is really, really competitive in Gen AI, and I think there are ways in which Java frameworks are actually ahead. Secondly, if you're building your applications in Java, there's a real advantage in Gen AI enabling them also in Java, because you can get at with tools and building your context, you can get at that business logic you've already got. Thanks. Okay, I think you are first.
So small little request before we start Q&A. One is, anyone watching on the live stream, please pop your questions into the chat and I'll get them answered for you. And two, anyone in the room, please use the microphone, otherwise no one online can hear you ask a question and it's got no context. So, first question.
First of all, thank you for beautiful speech. I want to ask that this is very useful, but I mean that for us as a developer who develops something for product, do you have some idea or how we can test it? That, for example, if we add a lot of difference, like a suggestion, it would be still improve our quality of result, or it's already reduce it? Do you have something like hacks? Because we didn't discuss anything related to testing, something like this.
So very good points. So with respect to testing, there are things that you can unit test around this, and you actually should, because although you obviously can't unit test the behavior of your LLM, you can absolutely unit test your prompts and hyperparameters. And sometimes you'll encounter problems where you didn't expect a result and it'll turn out you didn't put all the right data in your prompt. So you should absolutely do that kind of work and Embabel makes it really easy to do that. When you get to higher level testing, I actually think there is a new kind of testing that's becoming quite important, which is basically using fakes for virtually everything else. Like, for example, test containers maybe, but using a real LLM. And I think that is quite important. With our own internal applications, we put a lot of effort into that kind of testing. And there are also evaluations which are really very important. So far, we do have an evaluation framework in the Embabel agent experimental package module. To be perfectly honest, I've found that in general, it's probably fine to write your own little evaluation loop for what you're doing. And obviously you can do that using Embabel as well. But yes, evaluation is interesting and important. It can help you tune prompts. And also potentially if you're using a coding agent, you can actually put it in a loop with the coding agent where you're getting it to try to improve the performance of your evaluation. Okay, I think. Oh, sorry, the gentleman up here. He was very quick. Who
was it?
So it's been a great argument for a strongly typed fluent language for such a complicated API, which around the text, everything is very complicated and is slightly different between the vendors and is going to evolve. I think that's a great argument for your approach here. How do you see it evolving and how do you cope with the difference between different vendors?
It comes down, for more complex things like chatbots, it does really come down to evaluation, and there is no alternative to automating that. For simple things like this, if you successfully break things down, you actually get a lot more leeway. Like I literally switched today, I switched one of these to a different model and it behaved pretty much exactly the same. Model capabilities definitely improve continually, and different models are good at different things. So for example, I've done a lot of testing on this over the last couple of weeks. GPT 4.1 mini is actually better than any of the small GPT-5 models that complicated tool calling. So some models, of course, also are good at reasoning, whereas other models that are not good at reasoning might be good at tool calling. So yes, this will continue to evolve. They will generally get better. And I think the biggest change that we've seen in the last little while is that tool calling is starting to become pretty good in smaller models. One other thing that I would say in terms of development is don't only consider the development of the massive cloud models, consider the development in the smaller models, because you might be able to run some of those in-house, and they are absolutely usable for like these kind of tasks. This laptop is marginal. This is only a 32 gig laptop. When I get back to Australia, I have waiting for me my new 128 gig M5 Max. On that machine, I would easily have been able to show you everything I showed you today running perfectly well on a local model. So, you know, we're actually getting there. So I think that's a question.
Thanks. I actually have 2 questions, if that's okay. So earlier you did a few comparison with LangGraph. So in LangGraph, I'm hard coding the graph, so it's guaranteed I can reach the edge I want to reach. So if the algorithm is calculating the path, does it always take me to the same goal, or is it diverge based on the state? And second question is, how do you handle the options that are not picked? Are they marked as off table, or is it always recalculated based on the state machine input?
Sorry, I didn't quite catch the second question.
So the second question is, once you have a plan, you choose a path you want to take, how does the framework handle other options that are not picked? Are they being marked as off the table, or do they always being recalculated based on the state machine input?
Good question. Okay, so the first one, with respect to, it will always choose the same path. The path considers cost as well as you know, whether it achieves the goal. So the only case where it would be undefined is if you've got 2 paths that have the same cost, and then it will probably depend on the order of methods that it's scanned. We debate whether or not we should flag that as an error. We probably should. But even so, it would be able to tell you exactly why it chose the path, and its choice will be totally defensible. So in practice, it will do the same thing every time. The only reason it won't do the same thing is if it's incorporating dynamic elements like dynamic cost, and then obviously it will also record why it did that, and you want it to do the appropriate thing. With respect to the second one, very good point. When we execute something by default within the same agent process, we mark it as having run and won't let it run again. There are certain cases like chatbots where you have a long-running agent process where obviously the respond method you want to be able to rerun, and you can mark that so that it can rerun. So basically, if it tries plan A action and the plan A action fails, that will be taken off the table. And if there's an alternative, that will still be available, because anything that wasn't executed will still be eligible for consideration.
I'll do one of the questions. That's me. I'm going to do one of the questions from the virtual Java user group. So we have a question here. Is Embabel only comparable with Spring Boot? What do you think about Agentic AI specs for Jakarta EE?
I honestly think that specs are a waste of time. It's like this space is moving so quickly that even an open source project struggles to keep up. I think good luck with any spec initiative. I think that's honestly, that kind of thinking is not relevant in this space. In terms of compatibility with, you know, not without using it without Spring AI and without Spring, it's already possible to use Embabel without Spring AI. So for example, if you want to use it with your own LLM, and there is one pretty large software company that has a group where they're in production using some super secret, weird in-house LLM, and they very easily integrated that with Embabel. So it's quite easy to integrate with any LLM of your choice. Also in Embabel Agent Experimental, I think we've got an example where it's working on top of LangChain for J. We only use Spring AI really for very low-level transport. So we control the tool, virtually everything that's higher level, and just making that you know, pretty low-level call, we handle ourselves. With respect to Spring, I don't know if we'll make it in the Spring, in this Embabel 1.0 timeframe, but I do think it probably will be possible by summer to actually run it independent of Spring.
And one more, we've got a lot online, but I'm gonna do one more and then go back to the audience. We have a question around Embabel versus LangChain for J, specifically, if possible, from your perspective, which one of those do you feel kind of performs better? It's actually quite interesting.
Well, performs better is probably, I guess it depends how literally you take that. I don't think there's going to be any difference between the performance, because any application that you do that does Gen AI is going to spend like 99% of its time in the LLM. So you're not really going to notice any performance difference. I think that the Embabel model is superior. I think the API is nicer. With respect to LangChain for J, I really think the default choice of putting prompts in annotations is a very, very bad design decision. I think they're literally the worst place you could possibly put prompts. But, I mean, it obviously works pretty well. And, it's good that in Java, we have multiple choices. And I mean, I would have to say that when I last looked at the code in LangChain for J, it was an awful lot nicer than the code in LangChain Python. So
Over to you.
Thank you. I wondered how you would implement something like witnesses or guardrails within this. So keeping an eye, you sort of talked about emitting events. Is that the sort of approach that you would take with this?
So there's a couple of things you can do. One is you could write your action that actually invokes an LLM within the action and then performs logic on it. There is also work you can add guardrails that are potentially reusable in the framework. So that, to be perfectly honest, that came from one of our other engineers and I haven't been hands-on with it. But it is there and it's documented. By the way, our documentation is really pretty good. And also, I should mention that we have the hub where you can go and like talk to the documents. I think my colleague Jasper tweeted about that recently, but we should get it on the main website pretty prominently soon. So it is a chatbot that is built on Embabel. So it uses Embabel, Agentic, RAG, and Neo4j, and it works against our documentation and can enable you to ask questions of the documentation, and it's really quite good.
So within this framework, you've got quite a lot of structure, a lot of thought behind how you'd make it more cost effective. Comparing this to agent skills within the coding agents environment, do you see some of these principles being moved into that space anytime soon?
I think there are somewhat different design principles in the coding agent because, as I said, they can emphasize more autonomy because at the end of the day, you can stop them and intervene. Having said that, agent skills are a common point, and we do have agent skill support. Agent skill support is currently in Embabel Agent Experimental, but before 1.0, it will move into the core framework as a supported module. So you will be able to add your skills. You'll either be able to add the skills as an exploded directory, or you will be able to specify a GitHub repo and potentially even the branch or SHA that you want it to clone behind the scenes to expose your skills. Agent skills are a really interesting thing, and I think they're a good idea. There's part of them that's great and part of them that's questionable. The part that is great is the idea of progressive disclosure. And I think that's a really, really good idea, where you get a small part of the skill that goes into your prompt. And then if the LLM is interested in the skill, it drills deeper and it gets more stuff. That's a fantastic idea. It's also a great idea to have a consistent structure for this so that, different frameworks and agents can handle it. The part of the skills standard that's, I think, a little iffy is the notion of scripts. So skills can have scripts in there, and it is a little disturbing that they don't even tell you, for example, you can have a bit of Python that, say, uses pandas or a Python library. Doesn't tell you what version of Python, doesn't tell you what version of pandas. And the way in which this works is actually that if you So use Claude, and probably I haven't tried this with ChatGPT, but I assume it's the same. You can ask Claude, do you have access to a computer? And Claude will describe the sandbox environment that's available to your agent session with Claude. So basically, the way in which skills scripts work is they're evaluated. So for example, it can execute Python or JavaScript in that environment. It's an interesting thing, which, yeah, I don't know how offended as a computer science is to be by that. Like, you know, bits of code where you're not even describing the requirements of that code. But yeah, look, we absolutely get that skills are important and have full support for them. Skills, however, to work properly do need sandboxes as well. So that we have a sandbox module, and that is also going to be moved into the core framework in 1.0. Currently, we have only 2 implementations of the sandbox abstraction. One is with Docker, which actually works pretty well. And you can specify the Docker image that you want. So you can create your own image to do what you want. And the other one is basically it's not for production use. It's just like, well, really run this on my machine, which is okay for testing, but you certainly wouldn't want to use in production. But now there is, you know, increasing interest in sandboxes out there in different providers. So I think our abstraction's fairly good. So we will extend them to different sandboxes. But to get the script supportive skills, sandboxing is necessary. So just bear in mind that in order to do that, your application is probably going to have to do something like spin up Docker containers. It's going to have additional runtime requirements.
Could you please a little bit deep into how works your like a framework? I mean that, for example, how like something in console understand that it needs to run this specific action, not like others. And for example, if I create 2 action with the same method signature, how it's like a choose and
2 actions with the same method signature, it will choose based on cost if there's a cost difference. Otherwise, it will choose one. And the one it chooses will probably be the first one that is encountered in the compilation unit. As I mentioned earlier to the question up the back, arguably we should flag that as an error. But on the other hand, it's probably not harmful. I mean, if the contract of it said that it would do it. So the way in which the planner works is there is a planner abstraction, and we provide 2 implementations of it. One is the GOAP implementation. The other is utility AI. And they both have exactly the same action format. Utility AI is something that's also quite often seen in gaming. And so that basically doesn't need a goal. So GOAP will not do a thing unless it finds a goal. Whereas, or alternatively, you can specify a goal. With utility AI, what it does is say, oh, I'm going to do the highest value thing I can do right now. Then you can either stop it or you can keep it going. It'll keep going and it still finds things to do. There are definitely places where that makes sense, where you just want to explore a space and just see where you get. And one example where we typically use utility AI is chatbots, because the highest value thing you can typically do is respond to the user input. Then you see whether in the course of that response you put something else on the blackboard that triggered something else. If you don't, well, you're just done.
Questions in the room? Cool. In terms of online, we have a lot online, so we're not going to be able to cover them all, but I'm sure Rod would happily jump into the YouTube chat later. But we've got a few plus ones on this. So Embabel agents expose tools over MCP. Anyone who connects can call anything. No RBAC, no payload scanning, no audits. Is that something you're thinking about building into Embabel?
I believe in the latest snapshot, there is actually some security that's been added in response to community requests around MCP. So it is definitely something that we're looking at.
Amazing. And then we also have, we'll do one more. Let's see if I can kind of summarize this. Tool level authorization, DLP scanning on payloads, tamper-proofing audits, as something that belongs inside Embabel itself, as a Spring security style integration layer, or as a separate infra?
I think that we're definitely going to look to integrate with Spring Security. And I think that, you know, it's a very powerful project that solves a lot of problems. So I think that's definitely going to be one of the key things that we do on the security story. Obviously, guardrails, that's something that is within the framework.
Awesome. And I think we can maybe end on this one. We've got a question around what is the future roadmap of Embabel look like? What is the future roadmap?
Future roadmap is that we get 1.0 out, which, you know, is definitely, I would say, within the next 6 weeks. The things that we need to do for that, probably there's a few things that are in flight, but probably the biggest things, and we need to get the skills support, core framework and supported. That means we need to get the sandbox support into the core framework and supported. Then post 1.0, I would say being able to run independently of Spring is probably one of the things that we would hope to do relatively quickly post 1.0. But, you know, also a lot of it is issues that come up in the community and, you know, what direction people in the community want to go. Actually, one other thing that I think is going to be a big deal post 1.0, which is not actually technically part of the 1.0 release, will be our memory framework. The DICE memory framework, which is, have a look at the DICE project on Embabel. It's a pretty sophisticated structured memory approach, which also has the ability to tie into your existing entities, which I think has considerable value in an enterprise scenario. That project, I think, is extremely promising, but still, like, not quite ready for prime time. So, you know, post 1.0, really getting that hardened, I think is going to be really, really important. Because, you know, agent memory is a very important topic. Agent memory, I think, is often discussed in isolation from systems that already exist. People think that agent memory is something that just exists in AI land and no one thought about memory before vector databases existed. In fact, if you think, for example, what is my bank's memory of me? My bank has many memories of me, and very, very few of them are memories that humans write down in text. They are things like, I'm sure they remember my balance. I'm sure they remember how many accounts I've got. All of these kind of things are structured. Like, enterprise systems have memory. And, you know, as I keep coming back to the point that structure is important, and it isn't just in text. It is something that exists in structure, can be audited and reasoned about, and therefore we feel that the correct solution to agent memory should actually be able to tie into that. But yeah, I would say personally the thing that I'm probably most excited about post 1.0 will be getting memory really ready for prime time, because I think that will be really, really nice.
Thank you very much, Rod. I think we can have a huge round of applause. I think the Rod's also around for any more questions if you've got any you've thought of now. As a reminder, we're running AI Native DevCon. It's still on the screens in the kitchen. We'd love for you to join. I'm also looking for volunteers to help me run the conference. If anyone wants to volunteer, give up half your time to run around with me helping speakers, and then the other half you get to attend as a regular attendee. But other than that, thank you very much to everyone on the live stream for watching. vJUG will be back next month, speaker TBD. And we're always looking for speakers. So if anyone in this room or anyone online wants to speak, let us know. And I am not sure when the next LJC event is, but we will hope that it's soon. So check out the LJC site. And thank you, everyone. There's drinks and I think a little bit of food left at the back. And have a good night. Bye.